What's going on, you guys? Mr. Allen here with some properties of logarithms. You're going to be using these properties throughout your entire logarithms unit, whether you're expanding or writing as a sum and difference of logarithms, condensing, aka writing as a single logarithm, if you're solving logs, evaluating, all sorts of stuff. So we got to commit these to memory. The three main ones are right here, and then a couple special case ones that I wanted to throw in this video as well. So the first one here, we have log base b of x times y. So our argument's got to be positive here, all right, because that would fit into the domain of a log function. Our b value would be greater than 0, but not equal to 1, okay? I kept all that fancy stuff out of here. Let's work with the properties, all right? So your multiplication within the argument here is going to expand to what? Well, logs are exponents, and they follow the same properties of exponents, all right? Now, if I'm multiplying with like bases with exponents, quick sidebar right off the bat here. If I had x to the, say, 5th times x to the 2nd, what would I do with my exponents? I would add my exponents, I'd get x to the 7th, right? Same idea applies here. Since I'm multiplying within the argument here with like bases, I can add my exponents, aka add my logs. So this is going to expand to log base b of x plus log base b of y. Nice. Beautiful. Let's do a quick example, okay? Let me just make one up off the, off the top of the dome here, if you will. I'm going to go with log base 4 of, how about 16x z. Cool, all right? Equals. Well, I've got log base 4 of, I got three parts here, right? 16, x, and z. So it's going to expand out. So I'll have log base 4 of 16 plus log base 4 of x plus log base 4 of z. Now, there's a little more we can actually do here. A lot of times when we ask you to do these problems, we'll say evaluate if possible. Log base 4 of 16. 4 to what power is 16? 4 to the 2nd. So the final answer here will be 2 plus log base 4 of x plus log base 4 of z. Nice. There we go. Cool. One example in the books here, guys. It's awesome. It's fantastic. Let's move on to the next one here, right? And as we get moving, we can actually use these properties. We can use all three of these properties in an example. And I've got some examples in other videos of that where you can see them in conjunction with each other. This we're going with basics here, so I'll keep it to one property for each. Maybe I'll get a little spicy. We'll see. All right, log base b of x over y. So with multiplication, we need to add them, right? We connected that to exponents. What happens when I divide with like bases with my exponents? Right? So if I had, I don't know where I'm going to have room. It's going to be on my face here. Let's throw it on my face. That's fine. I'll throw it on my face. Ready? If I had x to the 5th over x squared, what would I do with my exponents? I'd subtract them and I'd get x cubed, right? Dope. On my face. All right. So I'm going to do the same thing here. When I expand this, it expands to subtraction. So I'm going to have log base b of x minus log base b of y. Cool? Important thing to note when writing your logs, especially when these things start to get kind of crazy, right? The log and the x are in the same line, same size font. The b is little and it's a subscript. It's a little bit lower, okay? Because otherwise, if you write it all in line, it starts to look like this is an exponent when it shouldn't be. And as you can see down here, we have exponents within logs. So you got to keep everything in line, organized, neat. Okay. So let's do an example here, shall we? We shall. We shall. How about, I'll do it in orange again, so all of our examples will be orange. Let's do natural log. What? Natural log, it follows the same properties, right? Log base 4, log base 2, log base 8, log base e, which is natural log. I'll do, how about 5x over yz. I already combined properties. Sorry, guys. I'm already getting crazy here. We got multiplication in the numerator, okay? So we got, I couldn't help myself. We got natural log of 5, multiplication, right? It's in the numerator, plus natural log of x. Now we're dividing. I'm dividing by y, and I'm dividing by z, right? Regardless if y or z is there, they're both being divided by those two, right? So it's going to be minus natural log of y and minus natural log of z. That's a tricky part right there. A lot of people put plus here because like, well, it's y times z. But if this y wasn't here, I'm still dividing by z, so this is still subtraction. It's more so about the location that it's in the fraction here. In the numerator, they're both positive. In the denominator, they're both negative. Cool? I can't evaluate that by hand, so we'll leave it as natural log of 5. All right? Already thrown in some crazy ones there for you guys. If you weren't ready for that, I apologize, but I felt like we just wanted to get after it. This one here. So I have an exponent here, our power rule, or like if you think about again exponents, I'm gonna write in my face somewhere. All right, I'll write over here so you can see it, and I'll get my face out the way. If I had power to a power, let's say, how about this? We'll use the same exponents. X to the 5th squared. What would I do with those? I'd multiply them because it's like x to the 5th times x to the 5th, which is x to the 10th. Shortcut is multiplying the 2. So that's what we're going to do here. This y can actually come out front here. And now I have y times log base b of x. Cool? Awesome. It's awesome. Let's do an example. Let's do it. I'm going to throw all three, okay? No holding back. No holding back. We're going to throw all three in this thing. I'm going to go log of, let's go with x squared over y z to the 3rd. Let's see if we got it in here. It'd be unfortunate if it didn't show. We got it. We got it. It's in the frame. Okay. What does this equal? Well, first off, log, where's the base? It's log base 10. If it's not there, it's log base 10. You don't need to write it, okay? It's implied. So I got log of x squared minus log of y minus log of z cubed. Now here's the thing. To be fully expanded, if we were asked to expand right a sum and difference of logarithms, these powers do need to come out. All right, and I'm in an unfortunate situation here. I'm going to come up like this, and hopefully I have the room. So we're going to have 2 log of x minus log of y. Log of y. There we go. And then the 3 will come out as a coefficient as well, minus 3 log of z. And again, the 2, the log, the x, they're all in the same line with each other. Here, the same went, but my exponents were up. Okay, so try to be as neat as possible. I almost lost it on the y there. I almost went low. But that would be my final answer for that one. That's fully expanded. And then our other questions are going to be like, rewrite this as a single log, and you'll go back the other direction. So those are 2 styles of questions we can ask. I give you something like this right here. You got to rewrite it like this right here. Or I give you this one. You write it like that one. Yay. Cool? Goes either way with it. Last 2 properties here, kind of special cases. I got log base b of b to the x. Well, this is pretty cool, okay? This just equals x. What? Well, why? Let me throw some numbers in here to give you guys an example, okay? Let me throw some numbers in to give you an example, and I think it will make a little more sense. So if I had, say, log base 2 of 2 raised to the x, what would that equal here? Well, how about this? Actually, I'm going to not x. Let's go with a number. Let's just go all numbers. Okay? Make it a little more tangible. What do we want? What do you want? Jenny, what's your favorite number? Her favorite number is 9. Okay. So we got log base 2 of 2 to the 9th power. So how do I figure that out? Well, I don't know what it is. So let's set this equal to some number. I'll call it n for this one. Okay? It's a bougie n, right? Sometimes we do fancy little kind of sort of cursive, I know. Big dog. All right. So how about we use our wonderful property here and rewrite the 9 out in front. So we'd have 9 times log base 2 of 2 equals what? Well, log base 2 of 2 is just 1. So 9 times 1 is just 9 equals n. There we go. Almost lost my train of thought. All right. So there we go. So log base 2 of 2 is 1 times 9 is 9. All right. So the shortcut of that, bringing that x out front, or throwing the 9 out front, whatever you want to do. You can remember if I see the same base there and that guy's chilling up there, I know that is my answer, okay? Same kind of process is going to happen here for the last one, b to the log base b of x. Well, crazy thought here, guys. It's going to equal x. Oh, what? Prove it, bro. Prove it. We're going to prove it with numbers, so it's not really a proof, right? The mathematical trolls of the world will be like, that's not real. You can't use that. You got to define your variable. Whatever, bro. Just doing street math. You know what I mean? All right, I'll use a different color than green. I'll go blue. I have it in my hand. So let's pick a number for b. All right, I'll pick 4. Okay, so we're going to have 4 to the log base 4 of some other number. Let's go with 11. Okay, so 4 to the log base 4 of 11. I don't know what that is. Let's set it equal to n like we did in the last one there. Now what? I can't like bring this 11. I can't really... This one, we're going to rearrange it in exponential form. I know it looks... Sorry, we're going to rearrange it in log form. I know it looks like we're currently... For this one, we're going to rearrange it now into log form. And you might be like, bro, what? There's a log in here. Isn't it already in log form? No. It's 4 raised to some number, log base 4 of 11, some number, equals n. That's exponential form. So if I loop and swoop this, I'm going to have log base 4 of n equals log base 4 of 11, my exponent, right? Log base 4 of n is this part, equals my exponent. Log base 4, log base 4. If those two are the same base, same log, wouldn't it make sense that the arguments n and 11 are equal to each other? Absolutely. Boom. There it is. There's my proof. Sort of. There we go, guys. So main idea here is if I see this, the like bases, there's my answer. If I see this, like bases, there's my answer. Cool? But that's the showing of how it actually works, okay? An informal mathematical proof. That's a lot, guys. Those are your properties. You got to remember these. These are the 3 biggies. These are the 2 special cases here. Pretty awesome. And have fun. Practice them. I got videos with tons of examples, so check them out and have a wonderful day.